Super. So good evening, everyone. So after Paul's lovely intro, yep, I'm Paul Battisson. I'm here tonight to talk to you about 5 answers to Salesforce questions you didn't know that you didn't know. When Paul asked me if I'd like to come and speak at the Cotswolds group, it was an immediate yes, and I was trying to think of something that I could share that A, I've not done before, so this is the first time this has been seen anywhere, and B, that was just a little bit different, you know, just hopefully can cover a broad base of things for different people. So Paul gave me a wonderful intro, but just a little bit about me for those that don't know me. I've been working with Salesforce for about 13 years now, 14 years, something like that. And prior to that, for my sins, was a .NET developer and a Java developer, and I've done iOS and all sorts of things. Currently, I am the CEO of Groundwork Apps, who are a Salesforce ISV focusing on building simple to use and easy to set up apps. We've just launched our first app on the App Exchange for sending SMSs. I'm also the Chief Technical Architect as a non-executive director of Eden Accounting, who is sponsoring tonight. As Paul mentioned, I'm an MVP Hall of Fame member, and I have 2 books on Apex programming out. The first is for admins who are looking to learn Apex, and the second that's actually the new cover of the 2nd edition that is not yet out yet. So this is the first public outing for it. And this is for more sort of advanced programmers, and I have a course on astronomical Apex testing, and this is all branded for Cloud Bytes TV, which is a YouTube channel I have. So loads of places to find rubbish from me if you are looking for it. But with that, what is the point of this session? So over the many years I've been working with Salesforce and banging my head against it, I've come up against a number of things that are just odd. Salesforce is genuinely probably the cleverest bit of software I've ever worked with. I think the way it works, the way it handles things, and we'll talk about some of these things later on, is really unbelievable. And I'm long enough in the tooth to have developed like a login system where you had to capture username and password and store them in a database and worry about sorting them and all these things. So Salesforce is brilliant and does so many clever things, yet there are so many slightly odd things it does as well. And this is 5 things it does that are odd or that you might have seen, and you might just kind of see them that often and you just think, oh, I don't know what that is, and just move on with it. So we're going to try and answer them and explain them tonight. With this, however, I am taking terrible liberties on some of the technicalities here. All of the stuff I'm going to tell you is true. It may be massively simplified and made easier because no one really wants to get into Java bytecode difficulties, but I have simplified a lot of this. So there will be a little bit of magic hand waving to explain things. That's not because it's not true. It's just sometimes to make things a little bit easier and hopefully to make it so that everyone here can understand, because I know we've got a mixture of developers and architects and users in the room and all sorts. So, so with those terrible liberties, if you bump into someone at Salesforce and they say that's not exactly how it works, you can go, well, there's your warning sign, it's a hand wave. Let's jump into the first one. So those of you that have been working on the platform for a while will have undoubtedly come across a null pointer exception. You'll either had one in a flow, you'll have had a developer that's written some code that is doing something it shouldn't be doing, and you get this wonderful system.null pointer exception, and it's a horrible red error you normally get, and it's normally telling you about some trigger code. And it doesn't really mean a lot. And so the biggest question everyone always has is, well, what actually is that? And I have known developers who have worked with, and consultants who have worked with Salesforce for 10 years who haven't ever figured out what it is. They've just kind of like, oh, there's a problem. What is it? So we're going to figure out what a null pointer problem actually is. And to do that, we're going to start with this idea of an analogous example. So on here, you can see a very crudely drawn family tree. And the more observant of you in the room might even recognize the family as the Simpsons. And so we have Homer and Marge, who are our main kind of parental characters here. You know, we have Homer's dad, Abe, we have Marge's sisters and her mum, and then we have Bart, Lisa, and Maggie. And so, we have a series of people here with relationships. And, in Salesforce, these can sort of be thought of as objects with relationships, and in code, they would be instances of objects with relationships as well. And so we can start to ask a few little questions about it. So, for example, who is Homer's wife? There's no need to shout out. This isn't the quiz. I'm hoping that the trivia is a bit more difficult than reading this. Homer's wife is obviously Marge. We can then say, well, who is Homer's son? And we can go down our family tree again and find Bart. And then we can start to interrogate Bart through his relationship with Homer. So what is the age of Homer's son? And we can go down to Homer's son, and then we can find out what their age is. And we can then ask a question as well, which might not have an answer. So who is Homer's sister? So if we try and find Homer's sister on there, well, Homer's an only child. He does have a brother, but after that whole fiasco about building the funky car, they don't really talk anymore. So we don't really have a sister there. So we can think of the sister as being like a non-existent or an empty object. If we were to put this in code, it would be null. And so when we then ask a follow-on question, which is what is the age of Homer's sister? What we're trying to do is we're trying to find out something about something that doesn't exist. So we're interrogating something that doesn't exist. We're trying to find out an attribute of something where we don't have an answer. And so we can kind of nudge this simple set of questions into really rough pseudocode. For those who aren't familiar, pseudocode is basically fake code that looks more like written English. And so we can say on our Homer object, the son property points to Bart. And we can say that the age property of the son property of our Homer, so Homer's son gives us Bart, and then Bart's age or Bart's age is 10. Canonically, Bart will always be 10. We can then go down and ask about Homer's sister. And this will be a null, because Homer doesn't have a sister. If we were to try and look at who Homer's sister is, we would just get a null, an empty. It doesn't exist. And so it's in code or in Salesforce, in the background, this is just an empty block of memory. It's just pointing nowhere. And so then if we try to get the age of our sister, we would be trying to access something on effectively nothing. So an attribute on an empty object or the null. And this gives us a null pointer exception. And so really all a null pointer exception is us attempting to access something that doesn't exist. So a null pointer exception, and our answer to this first question is, when we're attempting to access data that cannot be reached, as the object that should be holding the data is either not instantiated, so hasn't been created, or is null. And so whenever you see a null pointer exception in your flows or in your code, the first thing to think of is what is empty, what doesn't exist. A really, really common way of this happening is if you're trying to retrieve a record. So let's say you try to retrieve an account with a name of Acme, and then you try to access the number of employees on Acme, and you try to add 1 to it. Well, because if you can't retrieve Acme, trying to get the number of employees from that is null, and so you end up with this null pointer exception. So the problem with a null pointer exception is that it is incredibly obscure by its definition, because you don't know what you are trying to access that isn't really there. But it's not something that you should ever be scared about. And so whenever you're finding one of these things pop up, if you see the line of code that it tells you it's on, or you see what it's saying in the flow, have a look there, and 99 times out of 100, you can fix this just by making sure that something does exist for it to work on. So that's question number 1 sorted out. What is a null pointer exception? Now, question number 2 is my favorite ever interview question. So this is the question that I ask everyone who ever interviews with me, because I like to find out how people think. And the question is, why can't I have a roll-up summary on a lookup relationship? So within Salesforce, we have roll-up summary fields where on a master detail relationship, the master or the parent rolls up a bunch of information from the detail or child records. So for example, we could have an invoice that has a set of invoice line items, and we could sum up all the totals on the invoice line items onto the invoice to get us the total value. And we can't do this if it's a lookup relationship. And they're really the same sort of thing. There's no real difference in them. And we could actually have lookup relationships that are marked as mandatory now. So you have to populate the field, or we could have added a validation rule or something to that. So why can't we do a roll-up summary on a lookup relationship? So when I asked this question in an interview once for someone who was trying to get a role as a technical architect, The answer they gave was that Mark Benioff said so, or that Salesforce said so. And I'm afraid to tell you that this is the wrong answer. Mark Benioff, I'm afraid to tell you, first of all, is not that technically involved in such decisions. But it's not just because Salesforce are meanies and decided they didn't want to do so. There's an actual technical reason behind it. And so let's go back to our invoice example we had. So we've got an invoice here with 3 line items. As I'm sure all of you in the room can do on your fingers and toes if you all sit down together, you can add up the total of those invoice line items to £300. So if we have a master detail relationship, one of the things that happens is whoever owns the parent owns all of the children as well. So access is controlled by the parent. So that means that if Paul owns the invoice, Paul therefore owns and can see all of the invoice line items. And so Paul can add up all those values quite happily. With a lookup relationship, however, sharing is different. It could be that Jane owns the invoice and Jane might own one of the invoice line items, whereas Paul might own the other invoice line items. So if Jane then tried to do the roll-up summary, and let's say that the sharing was such that the child records were private and she couldn't see them, she would get an incorrect total. Or worse, she could get a value if we were doing something like a maximum date, or some information like that she couldn't see. So the reason that we can't do a roll-up summary on a master detail on a lookup relationship is because we're not authorized to. So a roll-up summary on a lookup relationship would break the sharing rules and structure. So one of the key things that I always make sure people are aware of whenever I'm interviewing, but whenever I'm working on a project as well, or doing any sort of implementation, is when we're putting in a lookup relationship or a master detail relationship, we need to know why, and does that really match the sharing model? Far too many instances in implementations just have things all marked as public. Everyone can access everything, everyone can own everything, everyone can see everything, or master detail relationships in places where we actually want the visibility to be different. Using the standard Salesforce out-of-the-box tools with the sharing model that it imposes is a great thing for us to do and allows us to control this properly. So make sure you know when you're using a lookup relationship or when you're using a master detail relationship, make sure you understand why you couldn't necessarily do a roll-up on there or could do a roll-up on there. And when you are using dynamic lookup, roll-up, summary, or any of these tools, be very, very careful. I have seen more than one instance of just implementations where DLRS or something is used and the data is skewed or incorrect because they can't see all the records to add up the total, or it's adding up a total and they're looking at the records and seeing a different number. And there's nothing more disconcerting to users than if they were to see an invoice that says 300 but only able to see one line item for 150. That would then make them lose confidence in the system for a start, as well as just start to probably create records or edit things, and we don't want them messing around. So that's the answer to why you can't do that. The reason I like this as an interview question is that most people I've come across don't know that off the top of their heads. People who I've interviewed for who are CTAs and things don't think of that off the top of their heads, but people can go through that quite nice and easily when you start to think about what the relationship differences are and come up with it. So there you go. It's an interview question that all of you can use now when you're interviewing admins, developers, and architects going forward. So question number 3 for us to figure out is, how do I calculate my data usage? And more importantly, why is it that way? So we've all gone into the system overview, I'm sure. So if you haven't, set up menu, system overview, it will give you a breakdown of your data usage, and then you can click and see what's using up most of the data in your org. The most common object that uses the most data is email results if you've got Marketing Cloud, or if you've got that integration set up, or email messages, and then something like tasks or contacts and accounts and things like that. When we calculate that information, it's kind of, well, we have these odd numbers where it all seems to add up and it's not really clear why. So let's look at what Salesforce looks like in the background. So, and when I say in the background, I don't mean what we're seeing in the schema builder. I mean what's behind the curtain. So Salesforce under the hood, in most instances, is still a large Oracle database. There are some differences now. This is hand-wavy time, but in general, it was set up originally, and for most instances still is, a large Oracle database in the background. And that database has some very cool features, and there's a very interesting paper by Salesforce that I think I'll link to later on. If not, I can drop it. Yeah, I do link to it later on that you can read. And it's in well architected and all this stuff. But Salesforce has some magic stuff that allows all this metadata to work together. And at the top here, we have what's called the Universal Data Dictionary metadata. And that's where you define all of your raw, all of your objects and all of your fields. So that's where all of your custom object definitions live, all your custom field definitions live, and some other bits and pieces. You've then got all these pivot tables on the right, which are where indexes, relationships, and denormalization, other magic stuff happens just to kind of make it easier for querying and searching. And then we've got these two data tables. Now, CLOB is for large data, so think unstructured data like large text areas, things like that. But here in MT data, we have one big table that stores all of your data. I'm going to repeat that again because many people don't realize this. One big table that stores all of your data. And so whenever you create a record in Salesforce, it actually creates records in one table. So if I go here, we get our GUID, which is our unique ID. We get the org ID that this record belongs to. We have the object ID, and then this table here, MT_data, has a long list of generic fields with value 0, value 1, value 2, value 3, value 4, value 5, and so on and so forth, all the way up until you hit the maximum. And these fields just store generic data. So they can store numbers, they can store text, they can store phone numbers, emails, whatever we want to stick in there. And that is then smashed together with our field metadata and our object metadata to tell us what it should be. And so when Salesforce renders a page for you in real time, it's going away and it's saying, get me that record, get me this metadata, I'll mash it together and know what fields should be what types they should be, and how they should be displayed. And it puts it out from there. And so when we're calculating data storage here, what we've got to think about is every single row of that table is set up for you to have the maximum number of fields on there. So whether you've got one field or 500 fields on there, this table is set up for you to have as many fields as you want, because per object, you will have a different number. So this record here with the AO1 object ID may have 10 fields on it. This one here, AO2, may have 500 fields on it, and this one here, AO3, may just have 2 fields on it. But the table stays the same size. And so whenever you enter a record, it's using up a row with all of those fields, even if they're blank. And so the amount of storage that each row of data you have takes up is 2 kilobytes, because that's the exact size of a row of data in an Oracle database when you've got the parameters set up like Salesforce have here. And that's how that calculation is done. So some caveats, email message is different because email message has large text fields. So if you have large text fields and binary data basically, and things that are skewing it, then they'll be slightly bigger. But if you have no large text fields, then it's pretty much 2K per record. It's always 2K, whether you're storing one record or 100 records. And there's a link there to the well-architected Salesforce Architects frame documentation where it talks about this. And I'll post a link in the chat after this to a really funny LinkedIn post that was put up the other day, where someone was predicting the next 30 or 23 years of Salesforce out there. And one of the things that they mentioned in 2025 was and this is a joke, this is not a Salesforce product that's coming, was the idea of small objects where it would take up 2 bytes. So if you were storing data for just IoT transactions, it wouldn't take up so much space. So that's also something to consider when architecting your solution, is if you are going to be creating hundreds and thousands of records that are just very, very slim and light, they will still be taking up 2K per record, even if they've just got 2 or 3 fields, okay? And you can sit there and start to do this maths now and work it out and see how much impact deleting or cleaning some of the data might have. So hopefully that makes sense. I can't see your faces, so hopefully people are still following along and enjoying this. So the next one is, why can't I do mixed DML? So some people might not have seen this error because it's a little bit of an esoteric one. But this error occurs when you try to perform DML, so an insert, update, delete, undelete, up or a merge on an object, so standard or custom object, and also a setup object at the same time. And a setup object is one of these special objects such as user, permission set, territory, profile, permission set assignment, business hours, I think is one. Yeah, bunch of ones in there that you can find. So you get an error like this, and it pops up on your screen as such. Now, there are many instances where you might want to do this. So, for example, you might, in the situation where you are creating a community user, so you're doing a custom handler for that, you might want to create the community user, so create the contact and their account, if they need a person account or just a related account, and then create the user record, and then create the then assign the permission set. Well, you can't do that because you've got mixed DML there. You're trying to do the operation on two records in one transaction, which is why for those who are Apex developers, you have the special site.create portal user, I think it is, or register user method. That method is there because in the background it kind of jumps out of the transaction and allows this to occur and send out the emails and everything without you hitting a mixed DML error. So why does this happen and what can we do about it? So the answer here is to go back to the diagram. So this diagram, which you're all going to spend hours poring over afterwards, I'm sure. In the top here, in the UDD, there's also sharing related records and permissions information stored. The UDD has a lot of, as you can imagine, this is a very simplified view of Salesforce's entire core infrastructure. So it's really cut down. They don't like to give that secret source away. But in the background, there is a lot of storage of permissions, sharing, etc., etc. And if you've ever created a share record through Apex sharing, then you'll know about creating those sorts of records. If you manually share something, it creates one of those records as well in the background. And so all of these sharing related records and permissions are stored there so that when you run a query, and when I say a query, that is a list view, that is a report, that is an actual SQL query, whenever you retrieve some data, Salesforce uses what's in the UDD to then filter out the data that it's retrieving from the MT data table. So the first thing when Salesforce is doing its first pass query, it filters out data that you cannot see. So if I had an account record, and if Jane earlier on had an account record, and I query the records, but they're private, Salesforce automatically filters that out based upon the sharing at the start. So what therefore naturally happens is, if you try and change both at the same time, it can't work out what you can and can't see because it's trying to do the transactions against the Oracle database in the most efficient manner, and it's trying to keep the database ACID compliant at the same time. So it doesn't like it. So that's what a mixed DML error is it's you trying to ask Salesforce to generate sharing records whilst you're also changing the sharing at the same time. And what could happen is, for example, Salesforce inserts a contact record, assigns the sharing on it correctly, and then you change the sharing by assigning a permission set, and that then clashes with a record that's just been created. So Salesforce does it in two transactions so it can keep things up to date. If you ever come across this issue, what you need to do is put something into a bit of asynchronous work. So either a flow that runs later on or a bit of future Apex, something like that. So that diagram we've used twice now. It's super useful. I really recommend that people have a look at that link I had in there earlier on if you really want to understand a little bit more about what Salesforce does under the hood and how it works. So the fifth question we have is, why is product called product2 in the API? Has anyone ever noticed this? There's product2 and pricebook2. Why do they have the number 2 on them? So we're going to go back in time. And I don't know if anyone else here remembers when Salesforce launched Salesforce 1, which is now the Salesforce mobile app, and there was a framework around building them. That's Parker Harris there in his Get Up at Dreamforce one year, dressed like Doc Brown from Back to the Future, and they had Huey Lewis and the News there playing Back in Time. It was a very surreal event. So way back when, there was in fact a previous product instance. So there's another object that Salesforce had called product, and they also had one called price books. And they had these product and price book options, but what they quickly realized is that they were a bit limited. They were having problems in scaling them. They were having problems in allowing them to work in the way they wanted to, with opportunities, with permissions, with defaulting, and things like that. So this was quite early on in the Salesforce lifecycle, so they rewrote them. And so what we have now is actually V2, and it's the only place in the Salesforce object structure that I know of, there's probably some somewhere, where everything is called 2. So you might ask, but when did this happen, Paul? You say it happened a long time ago, but how long ago is a long time ago? Well, I went and did the digging for us. It happened back in the Winter 07 release. So in spring 2004, Salesforce introduced this new price book and product feature. In Winter 07, they kind of negated the old product object. It was no longer available. And for those that like to count API versions, that was API version 8. We are now on version 58, I think. Yeah, 58. So I think 58. So 50 versions ago. And as you can imagine, that was Winter 07, so it'd be a long, long time ago. If you are ever really interested and bored, mainly bored, you can find all of the historic release notes for Salesforce at that link there. If you go back, the reason I've got the Winter 07 release notes here with our polar bear friend on is because they didn't have release note pictures for a lot of them before that. They also didn't have 3 releases a year for many of them before that, and didn't actually have full release notes with the API. So yeah, it's a really good, interesting thing to see how how Salesforce, as well as a company, has matured over the years in rolling stuff out. And it's one of those things that once you've been doing Salesforce for a while, you can go back to the first release notes you remember and just see how much smaller the product set was as well. When I first started working with Salesforce, what is now Classic UI had only been released just about. And so I've seen Classic be new and then get relegated again. It was I remember when it was all the exciting stuff. But Service Cloud was just a new thing as well. Like there's some really interesting things to go through those release notes and see. So if anyone's ever really bored, just fancies it, there's the link for it. So we've gone through the 5 things, 5 questions and 5 things you might not have known. But I wanted to give you a little bonus one as well, because this one is actually the one that I find very interesting myself. So the bonus question you might have is, why did Salesforce build Aura and then replace it with Lightning Web Components pretty quickly? I'm sure there's a bunch of people in the room that have been working with Salesforce long enough that they remember Visualforce, and it always was Visualforce, and everything was Visualforce. And then Aura being released and heralded as this big new kind of framework, this big push. And then it felt like within just a few years, Salesforce suddenly said, actually, forget about Aura, work with LWC. And I was actually working with a large global organization who, they had Salesforce in 120 countries. And when Aura came out, they started investing in migrating all of their Visualforce to Aura. And I'll let you figure out how many millions of dollars they were spending doing that and how much it was. Sadly, it was not a check that just came to me, but they were spending a lot of money with a lot of consultants around the globe doing it. And then Salesforce told everyone, hey, LWC is out, you should really move to that instead of Aura. And they got very upset. So why did this happen? Why did this happen? So way back when, and for the past few years, JavaScript frameworks were just everywhere and were a hot thing. So Google Web Tools in 2007, then XJS in 2009, then Knockout.js in 2012, Backbone in 2013, Angular in 2014, React in 2015. The one thing that JavaScript has is a new framework every 5 minutes. And what Salesforce correctly realized back in 2012 or late 2011 was that they needed to shift their development model from being page-centric in Visualforce to being component-centric and client-side. Otherwise, they weren't ever going to be able to really help people build apps, build things that could work on a mobile device. And it's important to remember that around this sort of 2007 to 2013 time, an iPhone was still pretty new. They weren't ubiquitous devices. So one of the things that Salesforce did was they started developing Aura as a framework in 2012. And the original goal, and I was really lucky that when Aura was first launched, we had Doug Chasman, who was the original architect for Visualforce, and in fact, I think some of the custom objects stuff from Apex before that. Come and tell us about how he'd helped develop Aura and why it was such a cool thing. And I remember him stating that Salesforce needed an enterprise-ready, secure framework for client-side development. Salesforce's number one thing is trust. They will always tell you it's trust and why trust is so important. But that's what they needed to be able to have, is that enterprise-ready, secure framework for web development. And they wanted it to have JavaScript, but it be friendly for Visualforce developers, because JavaScript at the time was also a bit of a mess. I mean, JavaScript is still a bit of a mess and will continue to be a bit of a mess for anyone who writes JavaScript. But it was a real mess back then. It hadn't really been updated in years. Chrome was still a really new browser at this point. People were still developing for things called Internet Explorer, if you can remember back to then. And so Salesforce developed this with the idea of making it enterprise ready, could work with all these systems and scale. And they released it at Dreamforce 2014. And it was a really good framework. It worked really well. The problem is that everyone else between 2012 and 2014, 2015 had also been releasing JavaScript frameworks. And the big two here are Angular and React, because Angular was written by Google and React was written by Facebook. And those two were kind of dominating, I don't know, let's say 60, 70% of internet traffic. And so, the people behind the JavaScript standards and behind the web standards realized they had to catch up. And so if we fast forward to 2018, when Lightning Web Components was released, lots of new frameworks had come out and lots of important underlying technology had been resolved. Okay, and there were standards. HTML5 had come out and been updated and was constantly being updated. CSS3 was out and constantly being updated. So ECMAScript is the official name for JavaScript in the background. Again, hand-wavy liberties there. But that had been stuck on version 5, I think, about 10 years, maybe longer. And then between 2014 and 2012 and 2018, 2 versions have been released. And now it's just an ongoing release because versioning is not really a thing on those fronts anymore. You also have the death of Internet Explorer. In 2014, it had 36% market share. In 2018, it was down to 3%. And there was a bunch of stuff that Salesforce didn't need to implement anymore. So this picture on the left here is from Salesforce. And if you look at kind of this split down the middle here on the left, everything in blue is what Salesforce had to develop originally for themselves. So a component model, templating, allowing customization, rendering it quickly, modules, events, all this stuff. But when 2018 rocked around, web components were a standard. Templates were a standard. All of these things, Shadow DOM for rendering was a standard. All of these standards had come out there and been accepted by both the W3C standards committee, so you knew they should be supporting all the browsers. All of the browser manufacturers had said that they were actually going to support standards as well, which was a big thing. And so Salesforce didn't need to build as much. And so it means they were able to improve things more rapidly. And so the reason Salesforce actually got rid of Aura was because they'd made such an investment in such a good idea, but thankfully technology had actually caught up with them. And so the real reason for the move to Lightning Web Components over Aura is nothing you might have heard to do with feedback or people not liking it or people complaining or trying to get more JavaScript developers in or whatever it is. It's really just that standards evolved. So standards evolved and Salesforce don't need to develop as much, and so they can much more rapidly improve the Lightning Web Component framework. And what I would say for the, you should do and look at, especially if you're a developer, is just how quickly LWC has added new features and moved ahead compared to how Aura was developing. and how much more rapidly it is. And so that's the end of our 6th question as well. And that's the end of the presentation. I hope you've enjoyed it. I hope you've learned something and found it useful. And yeah, thank you very much for listening. And if anyone has any questions, I'll be more than happy to take them.
Thanks very much, Paul. That was great. Really appreciate your insights there. Does anybody have any questions for Paul?